Well, hello there. Would you like to know something about chromatography? Well, I'm here to talk to you about it for just a few minutes. Okay, so if we were in lab right now, this is what our chromatography setup would look like. The first thing that you are going to do when you are setting up chromatography is you are going to take your stationary phase, which is silica paper. And you are going to, very carefully, without touching it, draw a line along the bottom with a pencil. Then you are going to take a small amount of dye and you are going to place little spots of dye along the line. Now, don't take our lines or our spots too seriously. We just are limited in our color choices with the markers. Pay attention to the data that you're actually given because that comes from a lab that was done in the past. Unfortunately, we don't have dyes available for us to do this for you today, but this is what we came up with instead. So you will take this silica paper with your line and your dots. You are going to place it carefully into a beaker that has a very small amount of a solvent. This solvent is your mobile phase. Your mobile phase moves up your paper via capillary action. So basically think of it like the paper is like sucking the solvent up it. So that is how your mobile phase moves. Your dyes, they move according to their attraction. If they are more attracted to or more alike to the silica paper, then they will stay put. If they are more like your solvent, they will move with the solvent and they will travel with that solvent front. Now, when I say alike, we are talking in terms of polarity typically. So if our solvent is more polar than our stationary phase, if our mobile phase is more polar than our stationary phase, and our dyes are polar, then they're going to move with the more polar mobile phase. However, if we have a non-polar mobile phase and it moves up, so it's less polar than our stationary phase, then our polar dyes are going to stick to that silica paper. So basically, if the dye is more like the stationary phase, it stays stationary. If it's more like the mobile phase, it goes mobile. Now, this is what your results might look like after doing an experiment like this. So here you can see our blue dye moved pretty far, our red dye didn't move quite as far, so we had some variation here. Now, this is our results of ethanol. So when you are doing chromatography, it is important, one, to stop your measurements before your solvent reaches the end of the page. And you will learn more about why this is. It's to calculate your RF value. You'll talk about it in recitation. If you want to know now, you can look in your lab manual. It goes through what your RF value is. But you need to make sure that you stop your solvent before it goes out of the paper. That way you can do those calculations. So ethanol, it's pretty polar. So you can see that in a polar solvent, these dyes moved really far. So when you are looking at results like this, you'll say, okay, if we had a polar mobile phase and our dyes went mobile, are our dyes going to be polar or non-polar? So I'm not going to give you the answer to this right now, but think about that. If they're going to be more attracted to something that's polar and moving up, what do you think that tells you about the polarity? Over here, this gives you another clue. Hexane is incredibly non-polar. Again, you will go over kind of what the meaning of that is when you are in recitation with your TA. But you will see that these dyes did not move at all. So our dyes stayed with the stationary phase in a non-polar solvent, and they moved with the mobile phase in a polar solvent. So think about kind of what that means and how you can interpret that data. I apologize that we don't have something better to show you right now. Hopefully we find something, but you will definitely see this in other labs throughout your educational career. If you have any questions, let us know.